Hello class. In this video we're going to cover activity 3.1, which is on page 197 from your textbook. From your last test we covered linear functions, functions that were in the form of y equals mx plus b. We're now going to explore a new function called the exponential function. So we start with an example. Your neighbor's son's going to go to college and is looking for summer work to help pay for tuition and books and all of those other things. So he says he'd like to work for 2 cents a day on the condition that you double his pay every day. So on July 1st, he'd earn 2 cents. On July 2nd, he'd earn 4 cents, then 8 cents, and so on. So it says, do you hire him? Question 1. I'd say yes, sure. 2 cents a day sounds pretty good. Then you're asked, how much will he earn on July 5th and July 6th? And then you're asked, what will he earn from the 1st through the 7th? So I guess we'd add up his pay on the July 1st, 2nd, 3rd, 4th, all the way through the 7th. So I think maybe it would be better if we complete this table first, and then we can answer questions 2 and 3. Okay, so again, on July 1st, he's going to earn 2 cents. July 2nd, he'd earn 4 cents, then 8 cents, right? We're going to double his pay every day. So my table looks something like this: 2 cents, 4 cents, 8 cents. You can ignore this third column for now, right? So on the first, he earns 2 pennies. The second, he earns 4 pennies. The third, he earns 8 pennies, and so on. So how much did he earn on July 5th? Well, we go down to the input of 5, and we see we have 32 pennies, or 32 cents. July 6th, he earned 64 cents. For question 3, what's the total for the first week? So if I were to add up July 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, I believe I get 254 cents, which is the same as $2.54. So just to verify, I'm going to take my calculator out and actually add up the first 7 days worth of pay. So I believe that was 2 plus the 4 plus the 8. Right? These are the values from the 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th from my output table here. When I press enter, yes, 254 pennies or $2.54. So question 3 is done. Right? Question 4 says complete the table. We've already done that. So we'll move to the next page. So we're asked, do you notice a pattern in the output values? Describe how you can obtain the pay on a given day knowing the pay on the previous day. So really, it looks like if we just double the pay on the previous day, we can come up with the present day, right? So for example, if he earns 2 cents on the 1st, well, we double that to get 4 cents on the 2nd. We double the 4 cents to get 8 cents on the 3rd, and so on. So when I go back to my table, right, we can see we're simply just doubling the output to move down this table. So I think we can write, we can double the previous day's pay to earn the current pay. And it says, use what you discovered in part B to determine the pay on July 9th. Well, if on July 8th we earn 256 cents, if we double that, we end up with 512, right? Because 256 plus 256 is 512. Question 5a, it says the pay on any given day can be written as a power of 2. Write each pay entry in the output column for the table in problem 4 as a power of 2. So for example, 2 to the 1 is equal to 2. 2 to the 2 is equal to 4. 2 to the 3 would be 8, and so on. And that's, I attempted to squeeze that in on the right side of our table. Right? 2 to the 1 is equal to 2. 2 to the 2 is equal to 4. 2 cubed is 8. 2 to the 4th is 16. Right? So our base is always 2, and the only thing that changes is the actual day. So if I say, what did this gentleman earn July 8th? I can put an 8 in for my power, and I do 2 to the 8th, and I get 256. Okay, so now they said, okay, can we write an equation to describe what we've seen? So if n represents the number of days, and p represents the pay, we can write this equation, right? The pay for any given day, right? Remember, n represents the number of days. So the pay for any number of days worked equals 2 raised to the n. So if I said on the 8th day, how much did he earn? I would say 2 to the 8, and I'd get 256. So now they ask, okay, well, what did this gentleman earn on the 20th? Well, if I raise 2 to the 20th, I end up with $1,048,576. Remember, this is in pennies. So if I move the decimal 2 places to the left, that would give me the dollar amount, right? $10,485.76. So in essence, $1,048,576 is equal to $10,485.76. Now, if I want to know what he will earn on July 31st, well, I'll replace the 20 with 31, and I'll raise 2 to the 31st power. And you see I end up with 2 million. Oh, I'm sorry. That looks like 2,147,483,648 cents, or $21,474,836.48. So I guess at the end of the day, was it a good idea to hire him? The answer would definitely be no, right? Because the last day, you're paying over $21 million. Next, we're asked to calculate the average rate of change. Now, you remember the average rate of change is the slope, which was y2 minus y1 over x2 minus x1, or we could say the change in the output over the change in the input. So we have two calculations here. For 6a and 6b, they're asking for the average rate of change from July 3rd to July 4th, and then they're asking for the average rate of change July 7th to July 8th. So I filled this in, right? Change in output over change in input. Now, instead of using x's and y's, we use the letter P for y and the letter N for x, right? Because P is my output and my number of days is my input. So from the 3rd to the 4th, remember from our table, if I scroll back, he earned 8 cents on the 3rd and 4 cents on the 16th. I'm sorry, he earned 8 cents on the 3rd and 16 cents on the 4th. So to calculate our slope, we would do the pay date on the 4th minus the pay date on the 3rd over the 4th minus the 3rd to get 8 over 1, which is 8 cents per day. And then we're asked to do the calculation for n equals 7 and n equals 8. And again, my pay for 7 and 8 was $256 for the 8 and $128 for the 7. So when I scroll down, using this same logic, right, change in output over change in input, we end up with 128 over 1, which is 128 cents per day. So I say, is this a linear function? You're going to tell me no, because the average rate of change is not constant, right? The slopes are different, so we know it's not a linear function, right? We have a function, it's just not linear. And then the last question on this page says, what's the practical domain? Remember, the domain are all the possible input values. So we're talking about the month of July, right? Days in July. So all the possible input values would be, I guess, 1 to 31, right? 31 days in July. So all the possible input values for July would be 1 to 31. So I would say n is somewhere between 1 and 31. Right? You might be used to using x and y because typically we have x on the horizontal axis, but in this case we're using n and p. Okay, so this is part 1 of a multi-part series to cover section 3.1. Thank you for watching.